Hi guys, Mrs. H here. Today we're going to be looking at the atomic structure. So at the end of this PowerPoint, you will be able to identify the parts that make up an atom, what an atom is, where the subatomic particles are located in the atom, the atomic mass, the atomic number of an atom, and then we also the following key terms. So remember that atoms make up all of matter, and that an atom actually has two parts. It has a nucleus and it has an electron cloud, and the subatomic particles are located inside those two locations. So subatomic particles are really, really teeny tiny things, and they're made up of quarks, and quarks actually came together during the Big Bang 13.7 million years ago. So let's look at this diagram of an atom. So if you look, we have protons, neutrons, and electrons. The protons and the neutrons are found within the nucleus, and then the electrons are in this outer sphere around the nucleus. Now, it's important to note that electrons are not stationary. These guys are spinning really, really fast and really, really quickly around the nucleus. And that's why it's called a cloud. You'll also hear it referred to as electron clouds or electron orbitals, and those are a little bit different, but we will look at that later. So what do we know about the nucleus? So the nucleus is held together by really strong forces that actually hold these quarks together. So these forces are sufficient enough to overcome the positive repulsion from our protons in our nucleus. But it can, an atom can decay, and they can break down because different atoms have different forces, or not different forces, it's the same forces, but they vary, their strength varies. And so sometimes we'll have an atom decay, and their rates of decay are different based on those forces from those subatomic particles. So looking at our charges of these particles, that's where those forces come from. So protons and electrons actually have opposite charges. So protons are positive and electrons are negative. And as a result, because the number of protons and the number of electrons are equal in an atom, atoms have no charge, or their net charge is zero. Now, when we get into future lessons, we'll look at how sometimes an atom can become an ion because the number of protons and electrons are no longer equal. But that's something we'll get into in another unit. So the other particle that we have in the nucleus is of the atom is the neutron. The neutron is a neutral particle, and as a result, they're not going to affect the charge of an atom. But each one of these has a mass. Now, protons are 0.998 of a mass, and we call that an AMU, or a 1 Dalton. A neutron also has one Dalton, or 1 neutron. Now, electrons are really, 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 really teeny tiny. So we usually negate or ignore the mass of the electron because that number is so small. And so that was what I was just talking about here. So the majority of the mass is in the nucleus because we have protons and neutrons having one mass. So if I have an atom that has 3 protons and 4 neutrons, we add those up, and that would give me a mass of 7. And so that's where the mass of an atom comes from. It comes from the subatomic particles of protons and neutrons. And we say it has a mass, or 7 AMUs, or 7 Daltons. And again, we ignore those electrons because they're so teeny tiny. All of this information can be found on a periodic table. We will also, it's another unit here we get into, is the atomic structures and how the atomic structures result in the organization of the periodic table. I have posted a periodic table for your use in this unit. online on the Google Classroom, so make sure you're utilizing that. And so all the information we need to know about an atom can be found on the periodic table. So if we look here, this it would be the box that we would see on that periodic table. And we have a number up here, this top number, and sometimes we'll see it on top of this symbol, and sometimes it's over here in the corner. It's always on the top, and it is always the smallest number. This number is the atomic number. The atomic number tells us how many protons that atom has. So in this example, carbon has 6 protons. We denote this with the letter Z to represent atomic number. Now, we have a second number on the box on a periodic table. This second number is the mass number, or the average atomic mass. Now, it's an average, so if I took all of the carbon atoms and I added it all up to find the average mass, this is the average. So there's not 0.11 of a proton or a neutron. It's an average. We use this number to determine the atomic mass. So I need to round this number. So this number rounded would be 12. What does that mean? That means carbon has 12 protons and neutrons total. We denote this with the letter A, and we can actually use the atomic mass and the atomic number to determine the number of neutrons. So let's see how we do that. So here's an example. Here is lithium. And so lithium has an atomic number of 3, or Z equals 3. It has an atomic mass of 6.94. So we're going to round that number to 7. So I can determine that lithium right here has 3 protons. And then if I subtract 7 from 3, I can determine it has 4 neutrons. Now, I also can determine the number of electrons, because remember, the number of protons and the number of electrons are equal in an atom because the charges are equal. So that means I have 3 protons. That would mean I would have 3 electrons. So here is a practice. Now I would like it if you would use your periodic table and the information given to you on this. Now I know it says it's that was on page 2, but I also posted it on the Google Classroom, the periodic table. Yes, you can look up all these answers and not have to figure it out yourself, but I'd like you to try right now using the periodic table alone, the missing information on this table, to see how you do. So how'd you do? So let's walk through hydrogen together. So on the periodic table, hydrogen's that first one up in the corner. So that means if you look in the box, the top number is 1. That gives us its atomic number. So that gives us 1 proton. The number of electrons were already given, but remember, 1 proton and 1 electron, same charges, so 1 and 1. So that makes sense. Now, the number of neutrons. The atomic mass of hydrogen is 1.00 something with a decimal point. Well, we're going to get rid of that decimal point because we're going to round it to 1. So to determine the number of neutrons, 1 minus 1 equals 0 neutrons. So hydrogen does not have any neutrons. So go ahead and look through the rest of the table and see how you did. If you have any questions, make sure you're reaching out to me and asking for help. Bye, guys.